All right, it is 1:00. Hello, everyone. My name is Mariah Meyer, and I'd like to welcome you here into the Dome Theater in the Viz Center. I am here joined by several colleagues from Linköping University to talk to you about a new initiative we have going on at LiU. And so I'm going to start and give an overview of what this initiative is, and then Marie, Hannah, and Conrad are going to talk more specifically about some of the really cool projects that researchers are doing within this initiative. So that's kind of the plan for the next 20 to 30 minutes. So, okay, feel free to sit down if you prefer. Okay, so like I said, my name is Mariah Meyer. I'm a professor here at Linköping University. My background is in computer science, and here at the university I work in a department called Media and Information Technology. And we're the department that is sort of situated around this museum space that I think you guys have been spending time in today. Conrad also is another professor in this department. And we, along with colleagues from across campus, have put together this new initiative that we call the Visual Digital Futures. And at the heart of this initiative is really about bringing researchers together to think about how we can design new digital technologies for the futures that we all want. So let's talk what do I mean by that? I debated even like putting a slide like this in because I don't think anyone would argue that technology has fundamentally changed our lives. And over the last several decades, in particular, those digital technologies and computing technologies, it's radically altered the kinds of frontiers of science and knowledge that we have come to know. It's given us all kinds of new capabilities in health, in businesses, in government, in industry. And it's also very much impacted the way that we live our lives and interact with people around us. So it's really pretty amazing, and the possibilities for what technology can do for us is really part of what made me want to go into computer science. But there's also, for a while now, there's been an ethos of a tech-centric design that Mark Zuckerberg kind of famously built into Facebook, 10 years ago about this idea of move fast and break things. And we're still, I think, sort of recovering from this kind of ethos about we should just build technology that we can imagine, let's get it out there, and we'll figure out later how to fix anything that it might break. But I think we're now at the point where we're starting to have to live with all those broken things. And one of the questions that engineers and technologists are asking a lot of is, how do we do something different? How do we harness the possibility of technology while not destroying the things that we hold near and dear? And so a question that we're asking here at LiU is, how do we design world-changing technologies without endangering our environment, our democracies, our values, and our future? And what we've done in this initiative is try to tackle this question by introducing this concept of the visual digital futures. So again, this is an initiative that is bringing together researchers from all different kinds of departments across campus together to think about how we could design technologies for the futures that we want. So, okay, I just want to break down this phrase a little bit to give you a better sense of what we're hoping to do. So first, digital. Linköping University has a wealth of researchers and labs here that are doing really cutting-edge computer science and technological research. A lot of things based upon data and big data, algorithms, AI, machine learning, computer vision, interaction modalities, and so on. All kinds of really cool technology design is happening here. And at the same time, a lot of this work is also very applied. So there's a lot of these technology researchers who are collaborating with people in areas like sustainability, in healthcare, in material science, to think about how do we bring new cutting-edge technologies to these various fields. So that's the digital expertise we have. But then there's also this futures idea. So we also have a lot of scholars and researchers here who think about what are the kinds of things that we want in our future? How do we think about technology in ways that takes into account ethics and values and integrity? How do we, what does it mean for people in society to interact with technologies, and what are those interactions that we want? And how do we bring people into, how do we take into the needs of a broad spectrum of people in providing input into what these technologies might be? And so that, coupled with a lot of expertise in design and how we can do a lot of participatory and co-design, how do we bring people directly into the context of how we're building and developing this technology so that it's for more people, and how do we bring this into the world? And so that's the futures part of this. And then there is the visual. And by visual, Linköping University is world-renowned for the research that we do here around visualization, which is basically how do we design visual representations and interfaces to data and to models and AI systems to help people make sense of it. So these visualizations in terms of this initiative are really important because what visualization allows us to do is to make sure that people are at the center of any sort of decision-making or analysis process that happens in conjunction with technologies like AI. So visualizations are a way for people to actually use and make sense of data and algorithms. It's a mechanism around which we can have discussions and collaborate. And it's also a way that we can start to really explore whole new ways that we could tell stories about ourselves and our communities and our environments. So taken together, we have researchers who are working across all these different topics that are coming under this umbrella of the visual digital future. And the goal that we have is that we want to design technologies that give people the capabilities, agencies, and responsibilities to tackle pressing societal needs and shape the futures that we want. So we're a new initiative. Things are just kicking off this semester. So in fact, this is the very first time that we are publicly talking about it. Thank you for that opportunity. And as part of this, what we're going to do is we're going to present 3 projects, research projects going on here at Linköping that fall under this initiative to give you a sense of the range of things that researchers are doing. Marie, who is a postdoctoral candidate in environmental studies, is going to talk about her work on the intersection of AI and climate governance. Hannah, who is a computer scientist by training and now is a postdoc in the gender studies department, is going to be talking about their work on synthetic data. And then finally, Conrad, who has a background in education research and specifically about how people learn about science through visual representations, is going to be talking about a new project here at the center that involves a talking planet. So with that, I'll pass it over to Marie.
Great. Hi, everyone. Very excited to be here today and to talk about my own research. So, as you know, it's all new. And from my perspective, I approach more maybe the future aspect. And I try to see how, knowing what these technologies can do, how can we maybe regulate them to be sure they are positive and they bring benefits to society and the planet and not the other way around. So my project looks at artificial intelligence for climate governance, and more specifically, I'm interested in how international organizations and states perceive AI in terms of what opportunities and risk it brings forth, and how it should be regulated, right? And for a bit of context, I'm at the Department of Thematic Studies, Environmental Change, which is an interdisciplinary department at LIU, but my background is in political science and international organizations, so that's the spin I'm giving to that project personally. And the starting point of my research is looking at the talk about artificial intelligence in all these platforms, you know, the United Nations, the European Union, the World Economic Forum, you name it, more and more they talk about how AI can help tackle climate challenges. So on the screen, you can see just one example here taken from the website of the United Nations Environmental Program, which deals with climate policy at the UN level. And they are really pushing that narrative of AI can help us tackle environmental challenge. AI can be useful for the work of the UN. But seeing that, I wanted to delve deeper, basically, in my own work. And so that brings it to the aim of my research, which is to investigate how international actors make sense of the role of AI in environmental policy and sort of what effect that brings, what future pathways are being opened in the way they talk about AI in their policy. And what does that mean in practice? Because maybe that sounds very fancy. Really, most of my time I'm in front of my computer to do my research. So I read a lot of policy documents. I work with surveys as well. I try to distribute survey and to sort of see if what I find in the documents hold ground. I also follow a lot of speeches, conferences, and I try to see how people who work in these international organizations and at state level, how do they talk about AI? So yes, that's what I do. And otherwise, when I'm not in front of my computer, I've been lucky to attend a few COPs, for example, and there I also follow the work on new technology that they do. I approach this problem from a lot of different aspects, so maybe to keep it short here, I'm gonna give you 2 examples that I've worked on. So I've worked at how AI and sustainability are approached by the United Nations and the European Union. And what I found is 2 main logics, if you will. The first one really pushes AI as a great tool for sustainability and more specifically as a tool to achieve the Sustainable Development Goals, if you are familiar with them. And if you try to dissect like the logic between the objectives, the problems that are identified and the solutions that AI is expected to help with. What we see is that at the end of the day, the objective is to have more justice and to fight climate change. So talking about future, what the UN and the EU really try to push is this prosperous future where citizens are well educated, they are healthy, they are happy, and they live in an environment that has not been damaged by climate change. The problem identified, which is quite interesting, knowing that what has been discussed and what technologies can contribute to, is that there is a strong idea that we lack data to make informed decisions and to have beneficial policies, and that's emphasized over and over again in their documents. There is also recognition that we have ongoing inequalities and that these inequalities are going to be exacerbated by climate change, and that needs to be tackled as well. So where does AI enter in that logic? Well, what the UN and the EU argue is that with AI, we can acquire and analyze more data faster and have more accurate results than what human could maybe do. And then with, especially with the internet, we can then share this information so more people can have the information and make informed decisions in turn. What's interesting is that the UN in particular is also pushing that AI can help empower vulnerable people. There is an interesting example in one of the reports where they used machine learning to analyze radio programs to see where, in a specific city, I forgot the city now, but in a specific city where women felt insecure, and sort of map the district where women felt insecure and why. And there is also this idea that with artificial intelligence, we can optimize economic activities and then reduce CO2 emissions, use less electricity, reduce waste, and so on and so forth. So in that sense, AI is very included within how they frame the problem of climate change. What is also interesting, though, is that they argue that for AI to have these benefits, it needs to be regulated, it needs to be governed. And there, some competing objectives come to the fore, mostly the fact that AI is used as an economic advantage as well, so it's an economic framing most, I would say. But also there is this idea that we should cooperate to make AI beneficial. The problems there is that both the UN and the EU recognize that AI can present risk for the environment and humans that needs to be addressed, but also that potentially the countries that develop AI first will have a huge advantage over other countries, and that could create inequalities and imbalance between countries. What they argue for to solve that is a collaborative but flexible set of rules to be sure that all actors are on the same page, but also be sure that we can adapt the policies based on technological development, because it can go quite fast. What's interesting also is that the EU really pushes this narrative that the EU should be a leader in AI. We should really be leading the market. And the argument, more than the fact that it would be good for the economy of the EU, is that European researchers and European countries can really push a value-based type of AI that respects human rights and that respects the planet. And the underlying argument is that the EU could do that better than, say, the United States or China, for example. The UN, on the other hand, tends to emphasize that for AI to be beneficial, we really need to be sure that what they call the bottom million is included. That's women, people of color, people in developing states, and so on and so forth. So yeah, these are two examples of what you can find in policy documents and discussion at the international level. But before I leave you, I would like to maybe share some thoughts I have with my own research and my results. What I see personally is that both the negative and the positive impact of AI on the climate are increasing, because we use AI and machine learning more and more to make sense of climate change, drought, floods, temperature increase, and so on and so forth. But also, if we use AI more and more, we are bound to potentially increase CO2 emissions, because training algorithm, it uses CO2 emissions. And I don't know if you're aware, but AI, it's not something in the cloud. We need computers, we need data centers that require space and materials, and that needs to be addressed. And so far, I haven't seen that being addressed very much by political actors. So that being said, what I see is that there are different organizations and states that have developed rules and strategies to harness the benefits of AI and limit the risks. So there's the UN and the EU. But in my work, I also look, for example, at Sweden, France, Colombia. I've looked at Morocco as well. And I really try to map these different approaches and see if there are differences or not. That being said, the efforts are only at the beginning. So it will be to see in the future how it develops. If I am to be a bit more critical of what I found, there is a strong economic focus on the economic opportunities brought by AI, which is not maybe bad in itself, but potentially it could hinder efforts to limit carbon footprint if regulating AI to make sure it doesn't emit CO2 emission goes against the profit margin that can be made, for example. Another thing that I think we should think about is that, yes, AI can help us acquire more data and analyze it, but is it really the solution to climate change, or is it the only solution to climate change? I think it's worth to have a discussion, at least, on should we use AI in complement to other more social approaches, maybe, for example. But I've gone over time, so I will leave you with that for now. Thank you for your attention.
All right, next up is Hannah.
So I'm going to talk a little bit about synthetic data, which is just, so data is anything that we can measure or like quantify, which, as you might imagine, is a lot of stuff and really broad. And synthetic data is anything that we made up measurements and quantifications for, based on stuff that we measured or quantified in the real world earlier. But we're like, you know, we're not actually going and measuring this table. We're saying, I know basically what a table is height-wise, and I'm just gonna like invent one. That's synthetic data now. But it's part of a larger project, operationalizing ethics for AI. So like actually trying to put into practice these like values and methods that we think are important for like doing AI well for the world. And it has two elements to it and a project group of 5 people mainly, so I'm one of them. And as Mariah said, I'm a computer scientist. My background's in computational linguistics. So I worked mostly on like the study of language, and I've done mostly language technology things. But we're a really interdisciplinary group of 5 people between us. I think there's like 6 or 7 different fields in this word cloud that I've just pulled from our public researcher profiles, but we have way more interests than that. We're all like really curious about how things fit together and how they work. And so we've like sort of added all of these things together to see where we end up together, like what's in the middle of that, the intersection. And so I use this illustration a lot when I'm talking about AI and when I'm talking about like statistical models. It's way simplified, and lots of computer scientists laugh when they see it. That's okay. But we're thinking about the world. That's the place we live. And then we're thinking about data. And that's, like I said, that's like stuff that we measured in the world. We observed it. We tried to put it into numbers. And the reason we needed to put it into numbers is because, I don't know if you knew this, but computers are very stupid. And they know on and off. That's it. That's all they've got. So we tend to translate that into 1 and 0. And from that, we can get all the other numbers. So if we can approximate the world as numbers, that means we can do something with computers to like communicate the world to them. So that's this like training element. And then models are meant to sort of predict what might happen in the world based on these previous assessments, where I can look at this and go, I know that's a table. I've seen lots of tables. They tend to have 4 legs. This one doesn't. So I have to sort of expand my conceptualization of table. A computer can't do that. You have to either tell it lots of rules about what a table is, or you have to show it lots and lots and lots of examples and have it like learn that this one is, this one isn't. But when we have those models, and then when we use them and we ask a computer, is this a table or not? Or later we're going to ask it, is this a dog or a wolf? That's another pretty common problem that we like to check in on. We're actually influencing the world, because we're not the only ones like making a call anymore about what something should be categorized as. Now we're like letting a machine do that too, which means that the machine is also part of our like social linguistic reality and the way we construct understanding of what a table is and what the world is. So the like overall question of this project is, how can we use AI for good without exploiting anyone, which is a very big question and really difficult to answer. One half of it is explainability, and the other half is synthetic data. Or at least those are the elements that we're interested in looking at how to do AI well. So this is a really classic example in computer vision, which is where we're trying to get images as data. Here we have a dog, and the computer told us it's a wolf, so the computer's wrong. And the research paper that I'm looking at here is trying to figure out why the computer's wrong. What parts of those numbers, that data, suggested to the computer that this is a wolf. And it turns out that what tended to happen is that it looks at the snow and not the dog. So whereas we as humans like understand how pictures work and what the like focus is in an image, because we're like familiar with art conventions and also sort of primed to look for faces and things. The computer doesn't have that. Every single pixel on that image, which there aren't very many in this large thing because I took a bad screenshot, but every single picture in this image is like the same amount of value to a computer. And what it turns out happens is that in the set of data that was originally shown to this program to try and distinguish between dog and wolf is that huskies are in people's backyards in like the continental United States, not in the snow, so they have green grass in the background. And wolves are in the woods in northern Canada, and they have snow in the background. So that's the like most reliable thing, is to look at the corners of the image and see if it's green or white. Well, the other question for synthetic data is just like, well, we'll just make up some more images. Like if the problem is that it hasn't seen enough wolves in a green environment, then I can invent some more. So I ran this through DALL-E this weekend and asked it to make a photograph of a wolf in a tropical rainforest. And first of all, I'm pretty sure that's also a husky. Second of all, it's not very photograph-like. And third, I don't think, like I'm not a huge tropical rainforest expert. Again, I'm a computer scientist, so there's a degree of like indoorness to this job. But I'm pretty sure that's the kind of illustration you see in like pictures of dinosaurs and not a modern rainforest. So we can ask like whether this is really a good representation of other pictures of wolves and dogs we might see. Maybe it would be better to just go back to this real image of a husky and do some Photoshop on the background a couple of times. That would also count as semi-synthetic manipulated data. But in theory anyway, if you had like good enough synthesized data, you could retrain that model and you could give it enough examples that have, you can like, so there's the imbalance, right? There's the problem that like wolves tended to have snow in the background and dogs didn't. And if we just like mix it up enough and we make those groups balanced so that there's an equal number of snow and not snow pictures across both categories, then in theory the model will do a better job. So that's about like messing around with the data in order to train a better model and like not put wrong things into the world maybe. But the issues that like most of, or a lot of the things that we're asking computers to do are a little more high stakes than is this a dog or not. So here's a Google Translate, also screenshot from last week, so it still does this as far as I know. And in Swedish we have the pronoun sin, which just refers back to the subject every time. But in English you can't do that. You have to gender the subject when you do this. I mean, you can use they or a neopronoun, so you could gender them more creatively than he and she. But you do have to pick a pronoun when you translate. And Google does this thing that we often refer to as gender bias, where it treats occupations differently. It gives them different pronouns, even though the computer has no context to know this. It's just happened to see that in English, nurses tend to have she attached to them, and doctors tend to have he attached to them. But that doesn't take into account like all of this stuff about the world that we know. For example, we might know that in Swedish, you're actually doing a better job if you guess she for a doctor. Statistically, they're more likely to be a woman. And yeah, okay, also in Swedish, you're more likely to have she for the nurse, but this keeps happening in numbers of things. And if you ask it like in French, where you have gendered nouns and gendered adjectives, if you ask, you translate from French or into French, like I'm beautiful versus I'm strong, you'll get a feminine for beautiful and a masculine for strong. So these like stereotypes that we have in the world are reinforced by machines. And there's a lot of them. I don't know if you've like interacted with the world recently, but we have a lot of expectations that we really like to put on top of each other all of the time. It's very hard to navigate without those. And so this like reinforcement becomes a problem. We have this influence and interaction. And it's kind of impossible to like really balance all of that data, just numbers-wise. It's huge, it's amazing. I mean, if you think back to this picture that I got Dolly to make, that took about a bottle of water and a quarter of my phone's battery equivalent just to produce it, not even to train the model that would produce an image. So I'm gonna use this example for like the foreseeable future because I feel bad about that amount of energy that I put into it. But if you sort of think about expanding that, like the sheer number of images I would have to produce to correct that one data set to get one problem fixed is really probably untenable. So synthetic data is like talked about as this magic duct tape to a lot of technical problems that we have. It's not real. We didn't get it from directly the real world, so it's like probably private. If it's not my data, then I don't have to worry about that being leaked into the world. And it might be unbiased because you can like deliberately manipulate how many examples you have of everything to sort of avoid this like nurse, woman, doctor, man problem. And you're gonna have enough of it. You're not gonna run into that like data sparsity problem because you can just make more when you don't have enough. But there's a lot of questions that come with this. Like if it's not based in the real world, does it still work when we wanna make predictions about the real world? If we want to know things that will help us make better decisions in the real world? If it's unbiased from ways that we knew to check for, what potential other biases does that introduce? Like, what did we not check for that now we have a different imbalance about? Suddenly I have a lot of wolves and dogs in my data set and oops, no sea cucumbers. Maybe that's important, I don't know. And when we're generating more and more and more, and when it takes like an entire bottle of water and a quarter of a phone's battery to generate one image, you have to wonder, like, what's the economic and financial costs of producing all of this data? It doesn't come for free, even though we tend to talk about it like that. So this is the sort of scope of the project problem that we're interested in looking at, is like, how do we poke holes in all of these concerns, and are there ways that we can try to do something that's like useful and slightly more valuable than we're causing issues with the concerns for. So it hasn't gone very far yet, because I've been working here for about a month, but this is what I'm interested in looking towards, and maybe you'd be interested in looking towards also, because it's going to take a long time. Thanks.
Okay, so, sorry. Oh, is the mic? Oh, the mic's back on. Thank you, back there. So our last talk today is going to be by Conrad, and he's going to tell you, as I mentioned, about this new project going on here in the Viz Center.
Thank you very much, Nora. Is the mic on? Thanks again. Absolute pleasure to be able to speak to you. It's so exciting when we get school classes to visit, and really, really nice to be talking with the colleagues here about a really important subject related to at least two of the other talks here, and that is the seriousness of AI being integrated into society and also being integrated into everyday life, and also being integrated in education. And I think that that is an absolutely enthralling place to be right now when we're doing research on how people learn. And we're hearing a lot about artificial intelligence systems that are based on large language models. So, you students out there, how do you use AI during your learning? Sorry? Yes? Sometimes, yeah, okay. Teachers, do you use AI during your teaching? Yeah. All right, so one of these variants is are chatbots, and you might have come across Neurosama if you are hanging around on Twitch. And this chatbot is really, really an AI guide through verbal and textual representations, basically scaffolding, having an opportunity to guide and scaffold your learning in this collaborative environment. So this verbal and this textual space is one of the learning spaces that you engage in also. There's also another important space, and this is the visual space that you're very, very used to. And here we have a visualization of global average temperature change since we started to start recording temperature. And you can see that there are changes here. You need to also really be critical visualizers. You have to be able to develop critical visual literacy. And this is one very important part of the visual digital future, because skeptics, they like to cherry pick the data. They like to cherry pick on the visuals and say, hey, no, well, there's actually parts where temperature is decreasing. But what happens if you bring in the visual aspect and you start visualizing things that are interactive in this learning space? Then you're able to model aspects of these in a dynamic, explore, and at the same time have an opportunity to explain the data in an interactive and dynamic way temporally. And you can start putting things together and see that, well, over 5 laboratories that have collected this information, there's a very high correlation of 0.98, that there's a high chance that temperature is actually increasing. So this helps us, through being able to explore and explain interactive visualized data, reach these types of conclusions. Now a question then, what happens if we can bring together these verbal experiences and these textual experiences together with these visualization experiences, and also have an AI guide in the mix. So what about actually having opportunities to have scaffolding, AI-enabled conversations in learning spaces like science centers and also the classroom? So the question about how visualization affects learning is something that our group here is very, very passionate about. And we're very excited to see how we can put these three things together as we move towards thinking about a visual digital future. For me, it started 25 years ago when I opened a textbook of chemistry and I wondered to myself, who decided that the representation should look like that? And if it looks like that, what do students, how do they interpret these? Now I'm very excited to be able to be part of this project that is going to look at investigating the possibilities and therefore, as Mariah said, the implications of AI-enabled conversational guides on learning, processes of learning, and our experiences in educational spaces like science centers and classrooms. So here's one of our PhD students, and he's working with an interactive visualized globe, visualizing information, and he is interacting with the data, he's exploring it, and he's also talking to the planet, and he's asking the planet to please go and take a look at a hurricane, and the AI guide responds and says, we will go to the location of Hurricane Katrina, how it looked in 2005. So all of a sudden, we have this AI-enabled conversation that takes place between the user or the learner, this AI guide, and visualized information that you can explore and explain. So therefore, the question arises, what can AI bring when we combine it with the need to also explore and explain data? So not just AI for the sake of AI, but how can AI be brought into the learning process in a very effective way? And if we're going to answer that question, we need to think about the AI guide. Is there a neurosama type of situation? Or what is the nature of this type of guide that we want to be looking for? We have to think about the pedagogy. The teachers in the room here, we have to think about what teachers think, because they're on ground level. What do they think are going to be useful and meaningful ways to integrate AI in these types of contexts? We also have to think about you students, you pupils, how you interact with data in the 21st century. Interacting with the guide, interacting with the data, interacting with each other. These are exciting questions about interactions that we need to also start answering. At the end, if we can get data about these and work out some patterns, we can start to say things about how this combination of visual and verbal spaces together with an AI guide can perhaps enhance learning. And if that happens, can we also use it as a way to increase access to different types of science, and also at the end, really develop curiosity? So that's where we're going to be going, at least on this project, in the next few years. And I also want to thank our funders who give us the opportunity to be able to do this work. And also this is part of larger other projects where there are very many interesting colleagues part of it, and I wish to also acknowledge them, and also perhaps more colleagues to join us in the future. Thank you very much.
No one wants to speak after Conrad. It's just such a letdown after that. Thanks. So on that last note, people getting involved, I just wanted to let you in the audience know that there are academic programs here at Lee U that you can get involved with if the kinds of things we're talking about today interest you, and in particular, one in the department that Conrad and I sit in, we have a master's of science in media technology and engineering that lets you come to the Viz Center and learn about all the different technologies that allow you to build the kinds of things that you all have experienced today, and that we, my colleagues and I as a collective, are interested in studying and understanding. So just keep that in mind when you all are thinking about your future university studies. So with that, I just want to say thank you guys so much for being here and listening to this inaugural discussion of the Visual Digital Futures. I will stick around. Maybe everyone will stick around for a few minutes if anyone has a couple of questions that they want to ask, or feel free to shoot me an email and I can send you more information. Thanks. Since we're a little over time, but yes.
Oh, sure. If you are in overtime, we can just take them later. Otherwise,
I can stick around. Yeah,
all right.
We're free if you all are.
Yeah. So when did this visual digital future start? You said it in the beginning, but I kind of forgot. That was my first question. And the second one is, do you know how we're doing globally in Europe against, I don't know, Southeast Asia when it comes to AI?
Maybe I'll let Marie answer that second question. For the first one, we are starting now, right now. We are just kicking off this initiative right now. We are planning to have a kickoff event at the end of November for researchers here at LiU to try to get people, or to let people know about the opportunities we have for basically supporting interdisciplinary research here on campus. So yeah, as I said, this is the first talk that we've given, so we're still really building this, the network that we have. We'll be giving another talk this weekend during Kulturnatten. But yeah, so it's just starting, it's just new, that's why I don't have a website yet. So it's something that we have funding for the next 3 years. Yeah. Marie, did you want to answer the second?
Hi, thank you for the question. I'm afraid I'm going to give a boring researcher question, which is, it's complicated and it depends on what you mean, I guess. If you mean who is dominating the market, that's for sure China and the US right now, with Europe actually close behind, if we take the European Union as a context rather than just Germany or Sweden. If you talk regulation, to my knowledge, the most thought through regulation we have so far is in the EU. Yes, that would be my answer.
Thank you so much.
I can, okay.
This is my student Victor.
Hi. Oh, shit. Conrad, I have a question for you. We're talking about AI and how that would enhance our learning in school and everything. Besides chatbots and visual learning algorithms with AI, what else could you think that we might use in the future that develops AI in our learning?
That's a fantastic question. Thank you very much. And we've also got another research project where we're trying to unpack the whole idea of AI literacy. Can an AI literacy even exist? And if it does, what are the components? It's so interesting because it's evolving all the time. So I think when it comes to learning, or at least in educational spaces at large, there's a whole lot of work that has implications, I think, for example, assessment. And also, for example, future predictions of learning spaces. So a word that sometimes gets thrown around about here is the combination of learning analytics with some of these tools. And I think there might be a really exciting way to start thinking about how your future learning might look before you even know how it might look, for example.
Thank you.
All right, well, thank you all for being here today. Yeah, best of luck. Best of luck with the school year. Thank you so much.
And if you want to ask questions not in front of the field, you can also do that.